Hi guys, today we're doing 9.4 looking at z-scores. We're going to use z-scores and standard deviations a little bit more in the next lessons. We're just kind of introducing them here. But let's talk about what a z-score is, fill in some blanks here, and then look at how to calculate it. So it says the value of a z-score tells you how many standard deviations you are away from the mean. Okay, so it's a way to kind of standardize a bunch of different pieces of information, some different data points, and you can compare them. We're going to be looking at like how unusual a certain data point is based on the z-score. So we'll get a little bit more into this definition later in this lesson. So based on this definition, if we calculate a z-score and we find that it's equal to 0, that means that it is on the mean. Right? If the z-score is 0, then it's exactly the same as whatever the mean is because we're 0 standard deviations away. A couple other pieces here. A positive z-score indicates that your raw data point is above the mean, and a negative z-score indicates a raw data point below the mean. Okay, again, a z-score is how many standard deviations you are away from the mean or from the average based on one data point. So let's look at how we actually calculate that. We have a little formula here. It's pretty easy. So our formula for the z-score, we're going to write z equals. So I'll write it out and then I'm going to explain what it means. We have x minus x bar divided by sigma, or your standard deviation. So off to the side, I'm going to write this exact formula, but in like regular words. So our x here, that represents the actual score, or actual data point, or actual whatever we're looking at. Could be a score, it depends. So actual data point, and then we're going to subtract x bar, that's our symbol for the mean. Okay, so actual minus the mean divided by, and from the last lesson, we learned that this symbol sigma, that means standard deviation. So when I'm looking at a formula like this, I don't read it in my head as these symbols. When I look at this formula, I read in my head actual minus mean divided by the standard deviation. Okay, so let's calculate. First example here, it says IQ test scores are normally distributed. We'll talk about that in the next lesson. But they have a mean of 102, a standard deviation of 19, and a certain individual score is found to be 124. So the mean, that's x bar, equals 102. The standard deviation, sigma, equals 19. And then our actual score, we say, is just regular x, is 124. So those are our three pieces. We're going to find the z-score. So we'll calculate it. Z equals. Now we're going to do the actual, so 124, minus the mean, 102, divided by the standard deviation, 19. When you type this in your calculator, I would suggest you either put parentheses around your numerator or you do it in 2 steps. You need to do the subtraction first and then divide. So if you want to type it at once, you need parentheses, or you can do 124 minus 102, click enter, and then click divided by 19. So when I do the subtraction, I get 22 divided by 19 equals 1.158. So what that means is that this score, 124, it's a little bit further than one standard deviation away from the mean. Right? Well, that makes sense. Standard deviation is 19. So 124 is 22 points above the mean. So it's a little bit more than one standard deviation above the mean. Okay. Now let's look at another example. Here it says the average profit for a celebrity chef restaurant is $325,000. So average, that's another word for mean. So I know X bar, 325. With a standard deviation of 35,000, so sigma equals 35,000. Now this time we have two different restaurants. So it says which amount is more unusual, a restaurant making $405,000 or $299,000. We're going to use z-scores to justify this. Okay, so a mathematical decision, not just saying, well, seems like it could be one or the other. So we're going to find the z-scores for both options. So the first one, we'll say this is our actual for the first one. So 405 minus the mean, 325,000, divided by the standard deviation. Okay, now I'll calculate that. Again, use parentheses if you type it in all at once. I got a z-score of 2.286. Now let's do the same for the other. So here's my other actual data point, 299,000, but the mean and the standard deviation stay the same. This time I calculated, here I got a negative z-score, so negative 0.743. So when I'm looking at these two z-scores, it's telling me how far away, how many standard deviations away the actual score is from the mean. Okay, so if I want to decide which one's more unusual, I'm looking at which one is further away from 0 is one way to think of it, right? Because this one's positive, this one's negative, but this value is further from 0. Okay, it's not just because it's positive, but 2 is further away than 0.7 from 0. So I'm going to switch to typing here. This one is more unusual because the z-score is further from 0. So when I'm asking you to justify your answer, this is something I'm looking for, a sentence like this. It's more unusual because the z-score is further from 0. Okay, so on the next page, you have a few examples to try, 3 examples. I'd like you to work through all 3 of those, and then you can check your answers. All right, here are my answers for those 3 problems, so you can pause the video to look closer at my work. Number 1, I got a z-score of negative 0.833 repeating. Number 2, I got a z-score of negative 2.7. And then number 3 was a comparison. So I have my 2 z-scores, 1.6 and negative 1.8. So the temperature of 58 degrees, that's more unusual because the z-score is further from 0. So again, when it says justify, you need to make sure that you're actually writing a sentence like this one. That's what I'm looking for when it says justify.